Hello Year 9, so this is your second lesson of an electricity recap for your home learning topic. Just to remind you again, that even though this is something that you've done before in Year 7 and 8, it's really important knowledge for GCSE, and that's why we're recapping it this year, to make sure you've got everything that you need, because I think it will be one of the topics that you missed in Year 8 because of lockdown as well, so it's really, really important. So make sure you've read the instructions on the slide. Remember, you can always ask your teacher if you need them. So last lesson I asked you to think of the word that links these three images. So the first one was current, spelled slightly differently. I haven't spelled that wrong, it's not a typo. Current, the fruit, is with an A. Current flows through rivers, and current, electric current, flows through conductors, which is what this lesson's about. So you can get this informed part of the lesson one of two ways, and it's up to you how you do it. So you can either watch the video and make some notes by clicking on the video link, the box points to that, or you can read through the next slide. It's up to you. So this is a slide that you'll be reading through. So a conductor is a material that allows charges to flow easily, so it does not provide much resistance to electricity. Something like a metal is a conductor. An insulator provides a lot of resistance to electricity. It does not allow charge to flow through it. Things like glass, rubber, silk, plastic, they're all insulators. So why do metals conduct electricity so well? So if you look at this kind of moving image, you've got those little negatives that are flowing through all those positives. And that's because metals are made up of a lattice of positive metal ions. A lattice just means a regular pattern, and electrons are able to move freely through that lattice, and they're called delocalized electrons. That makes metals really good conductors of heat, which is why we use them for things like saucepans. Metals are good conductors of electricity because of delocalized electrons, which are able to move through a metal and carry a charge. Okay, so you now need to do task 1 and 2 from the booklet. And again, this has been printed for you or uploaded as an assignment. So just task 1 and 2, and then come back to the video when you've finished. So hopefully you got an okay with those 2 tasks. So this is an experiment that's been set up. And what the student has done is to put different objects in between the crocodile clips. So you need to think about the questions on this slide. So how will you know if it's a conductor? How will you know if it's an insulator? And what kind of materials will be insulators and which will be conductors? So have a think about those questions. So a circuit's set up and different objects are connected to crocodile clips. So you need to have a look at the results of this experiment. So this is the experiment again. So are they expected, or are there any anomalies? So have a think. You might notice that the wooden pencil says the bulb lit up. Now, I would not expect usually a wooden pencil to conduct electricity. I'm going to find out why that is. So why did the wooden pencil conduct electricity? Does this mean that wood conducts electricity? No, it does not. Wood does not conduct electricity. Pencils are made of graphite and wood. And graphite contains delocalized electrons, just like in a metal. So graphite is able to conduct electricity. So if the crocodile clips are connected to the graphite, the bulb will light up. But if they're connected to the wood, it won't. What you need to do now is to complete tasks 3 to 5 in the booklet, which has been printed for you or uploaded as an assignment on Teams. So have a go at those and upload them so your teacher can give you some feedback. And there's one more task to do this lesson, and that's your Connect activity, which is a part of your booklet, and you need to read the information so you're ready for next lesson. If you prefer, there's a video to go along with it too, so you can click on the link and watch the video. Thanks, and I'll see you next time.